Hello everyone, I'm Mingqi Han and this is the video explanation for homework 2, question number 2. So here we have question number 2. It says that a signal passing a noisy channel will result in a signal because it's a signal is either 1 or 0, and so the output will be also 1 or 0, but the probability will be from the input probability, the output will change accordingly. So from the question that we have that the initial probability of getting a 0 is 0.2 and initial probability of getting a 1 is 0.8. And by passing through a noisy channel, notice that every noisy channel in this question are the same. So that by passing any of the noisy channel, the previous function, the previous input, the input would be 0 and the output would be 0, has a probable, the output probability equals to 0, given that the input is 0, have a probability of 0.6, and the probability of given input is 0, output is 1, is 0.4, and for and the others are 0.3 and 0.7 respectively. And the question asks to find the probability of A, find the probability of x2 equal to 1. So it means that this signal is equal to 1. So it's the initial signal passing through one noisy channel, and the output signal would be 1 with that probability. So here's my solution that I have listed the initial input, and so what I really need to do is to find out, given input is 0, output is 1, that probability, and given input is 1, output is 1, that probability. So it's pretty much straightforward. It's just this probability times the initial input, the probability of having that x equal to x1 equal to 1, that input, plus this probability 0.7 times the probability of initial input is equal to 1. So here's the equation, and here's the answer. And part 2 asks, part 2 asks to find, part B asks to find the probability of the third, i.e. there's two noisy channel, a signal input, and at the end of the second noisy channel was the output. So it's basically the same because we already calculated that the output probability of the second channel, the first output, second input, we can use that also calculate because the probability of the first output is equal to this. So the first output is equal to 0 would be 0.36, is 1 minus 0.64. And having that, I can use the same same way that I calculated the first one, just 0.636 times 0.4, which is the probability of the first one being 0, the second one being 1, or this would be k, this would be k plus 1. And just do the multiplication and do the addition. That's the final answer for P x3, or the second output, third input will be equal to 1, is this value. And for part C, what I'm trying to find is that given that the third input, second output is equal to 1, what's the initial input? Oh, sorry, the initial input is equal to 0, that probability. So this seems like a little bit counterintuitive, but by diagnosing this value, or this part of a probability, I can just get this. This is pretty much just take this out, put over here, and also here, but it's already x1 equal to 0, right? So this has to be here, and this x1 equal to 0 is just get out from here. And by do this calculation, by calculating this this function, I can get this value. It's just plug in the numbers. By the way, there's this part where probability of x3 equal to 1, x1 equal to 0 is just because we already know that x3 is the output of x2, and we can get x2 with x1's input. So just do the calculation, do this, and do this. We get the probability of this part, and plug it in to here to get the final answer. And the part D asks to find the limit, or as if there's infinite number of noisy channel, and the input would be also this, what the output would be. So if I do it the same way as I did with like question part A or part B, it will be impossible because it's an infinite. The n is equal to infinite. There's infinitely many noisy channel, but by looking at part B, I can already see that what I'm doing is just stacking the probability from the output of the previous one to the next output, or the input of the next one. I think that's right. Yeah, and so it all stacks up. So what I can do is to have this kind of function, because in previous part, what I calculated is partially of this. It's just this part and this part for, I believe it's for question part A. I didn't calculate this part, but because it's a limit and I have to do it recursive, sort of recursively, and there's a n to the infinite. So what I need to do is to calculate this part and get the after infinitely many noisy channels, what I can get, the value I can get, right? So by solving this equation, I get 3/7 and 4/7, which respectively is output is 0 and output is 1 at a x equal to at a n infinitely output. So this value is the answer that I need, and that's it.